Okay, we're proceeding along, and hopefully it's getting a little bit easier for you. What I mean by that, you know that the routine at this point. Again, we're going to be doing the materials for exercise 14 now. Again, my name is Ron Bannon. If you need to reach out to me, my email address is Bannon, that's B as in boy, ANNON.US. All right? So again, just to remind you, there's contents that we're expecting you to read through. There's examples that we're expecting you to do and understand. And then there's exercises for you to do to reinforce what's being taught. All right? So let me just kind of scroll through. And again, as I scroll through this stuff, it's not for you to read it. It's just for me to just remind you that we're looking for certain patterns. And again, it's still factorizations, all right? So again, you would read through those things. And again, it's important you do that, all right? So what I want to do is over here is, I'm looking at this over here, and certainly I'm going to say, sometimes I try to summarize what Wells just said, and I'll point this out to you. Looking at this over here, I make some summary. And basically I'm making a summary about problems that look like this. And then I talk about the expansion of a problem. And then I start to see that, the sum m plus n, the coefficient of the x, is the product mn, which is the coefficient b. Let me point that out to you. And what I'm saying over here is, you see this over here, and you see this over here. All right? So, a lot of students see it that way, and there's nothing wrong with that. I'm not saying it's a bad idea to do that. But, we have a general rule for that. And we'll get there, and it's called an AC rule. But the bottom line is, we really don't need a rule for simple problems. When the coefficient on the x squared term is 1, they tend to be incredibly easy questions. And what I mean by that, just by simple trial and error, there's a really good chance by trial and error you get it. But I will talk about that beginning AC rule problem, all right? So what am I looking at? 45. Someone says, how could you get 45? There are a variety of ways of doing it. 45 is a product. Could be 45 times 1. It could be 3 times 15. It could be 9 times 5. You get the idea. There's a variety of possibilities over here. So what they're kind of saying for you to do, though, was to look at the product and look at the internal term and wonder what two numbers you get. So I think you probably know that we need the sum to be 14 and the product to be 45, right? So what two numbers would give you a sum of 14 and a product 45? Well, that would be 9 and 5. So let me write that down. I still would check it. What do you get? X squared plus 5x plus 9x plus 45. And this is the factorization. If you look at the answer key, it's staring at you, all right? Let's take a look at the next one. And again, what am I doing? I'm making assumptions that I can do it. And that's a good assumption to have at this level. What do I need? I need to find two numbers whose sum is minus 5 and product is 4. All right? So I'm going to say that doesn't look too bad to me. I'm going to say minus 1 plus minus 4 would be minus 5. That's a sum of two numbers. And the product of those two numbers is going to be 4. So I'm looking for a sum of two numbers that gives me a minus 5, and a product of those same two numbers to give me, maybe I misspoke there. I want two numbers whose sum is going to be minus 5, and whose product, the same numbers, would be 4. And I just found them. So it's going to be minus 1, minus 4. I still would check it. This is x squared minus 4x minus x plus 4. And it certainly does work out. And circle that. And you certainly look at the key. All right? And this is something that's, not a bad thing to be doing. But my goal here is you could basically do it without all that yammering on about it. And you do that by looking. And this could get tough. I'm not saying it's going to get easy for you. But what are we doing? We're looking for two numbers that add together to 6. And those same two numbers would give me a product of minus 16. So I'm looking at that, and I'm going to say 8 and minus 2. 8 and minus 2 when add together gives you 6, and 8 and minus 2 when multiply together give you minus 16. So I'm going to write that down. X plus 8 and minus 2. I still want to recommend you check it. That's x squared minus 2x plus 8x minus 16. Does it work? Yeah, it works beautifully. Again, we provide the answers for you as well. All right? Let's keep going. Now, a little more difficult. I'll tell you why it's more difficult. They got a bunch of letters in it, and there's a fourth degree polynomial. But again, the assumption is I can do it. Let me write this down for you. x4, whoops, not x4, it's x squared, right? Let me get that again. x squared. And again, I'm going to say I could probably do that with all this work over here. But, I know there's this AB in the problem, so I'm just going to put it down AB. It's the numbers I'm struggling with. So what do I need? I need two numbers, when added together, to give me -1. And I need two numbers, when multiplied together, to give me -42. That's a challenge, isn't it? Let's take a look at that. And I'm looking at that. I'm wondering, what two numbers? I'm not looking at the sign necessarily, but I'm going to say maybe it's around 6 and 7. So I'll put that down here. I'll put 6 and 7, because I know they're different by 1. And I know their product would be 42. So I'm going to say it would be -7. And then what do you do? Let me see if that's true. -7 times 6, that's 42. So what are the two numbers? +6 minus 7. I'll write that down. But I think you know what I'm going to say now. I want to check it. I want to see if that's right. So what do you get up there? x4 minus 7 ab x squared plus 6ab x squared minus, 6 times 7 is minus 42, right? A squared, b squared. Now, it does work. What do I mean by that? I know I got the first term. I know I got the last term. That's generally a no-brainer. I certainly get the middle now, and that's the middle over here. So this is the answer. Not wishful thinking. Check it. Make sure you got the same answer. All right? Let's do the next one. And again, I'm looking at it, and someone says, oh, it looks so much more complicated. I want to rewrite that. No. Do this. It's got to be 1 and 1, if it's going to work, by the way. And then I'm looking at, I'm looking for two numbers. I'll write this down for you. I'm looking for two numbers that add up to 2, and I'm looking for two numbers that, when multiplied together, would give me -99. All right? By the way, I do know A and A at this point. I know that much. So what are the numbers? I'm looking at it. I'm going to say it looks like 9 and 11 to me. All right? And what am I going to say? I'm going to say -9 plus 11. Does that work? Well, -9 plus 11 is 2. And -9 times 11 is -99. So let's write that down. And I will check it. -9 plus 11. Let's check it. What does this give me? And I got to be careful with this. I got to multiply it out now, right? So 1 times 1 is 1. Then I get 11a minus 9a minus 99a squared. Do we get what we expected? Yeah, we do. 11 minus 9 is 2a. And the first term and last term work beautifully. And it really does. All right, let's look at the key. And the key's right over here. All right, let's keep moving. And this is number 6. And, my bottom line is I know it's tough. And certainly when I know it's tough, someone says, what are you going to do with this one over here? I don't know. Maybe I should rewrite it. And I'll write this down. -1 times x squared, right, minus 5x minus 24. Now, some students ask me, do you need to do that? No, I don't think I'd want to do that, but some students want to do that. There's nothing wrong with that. So what am I doing? Well, I'm looking at it, and what do I need? I need the sum of two numbers to be -5, and I need their product to be -24. Right? What two numbers would do that for me? Well, I'm looking at it, and I'm going to say 8 and 3 would be a good candidate for that. And what's that going to be? -8 plus 3. And that certainly works out. So let's write that down. -1, that would be x minus 8, and then x plus 3. Now, I'm going to say that's a fine answer, but you might be surprised if you look at the answer key, you don't see that answer there. I also want to go back over here and point out, I don't think I would do that. I would look at this thing and just simply say, 24, that's the first one. I may not know what the product is, but I know 24 has got to be a product of two numbers. And the x on the end is the easy one for me, x and x. Then I would look at the 24, and certainly just thinking about it, it's going to be 8 and 3. I'll write this over here. And I'll tell you why I believe it's 8 and 3. I'm seeing the product being 24, and that sum in the middle is 5. But this is a trouble for a lot of students. They look at it and have no idea what to do. You got to try. That's the idea behind this. So I'm going to say maybe something like this. I'll try it out for you. I don't know if this is going to work. 8 times 3 is 24. And then what do you get? Plus 8x minus 3x minus x squared. And what does that give me? 24 plus 5x minus x squared. It works beautifully. It does. I also want to box this as an answer, but I want to claim to you that it looks strange to me. So what I want to do is I want to associate the minus 1 with the first term, x minus 8. And if you did that, what would you get? You would get 8 minus x. Again, if you associate these two terms together and multiply it out, you would get 8 minus x. And then what do you see? X plus 3. And I'll put a box in that. And that's also a good-looking answer. Someone says, oh, one's in different order than the other. Well, then you could write this down, 8 minus x. Addition's commutative, so you could write this as 3 plus x. So there's a variety of good answers, and everything in a box on it, as far as I'm concerned, is a good answer. It's a good answer, every single one. What answers do they list? This one here, and that's right there. And they list this one over here, and that's this guy over here. All right? Let's see. Let's keep moving. Well, I think we're done. So when you're done, there's going to be more examples for you to do. And those examples are actually called exercises. You kind of exercise now. You see if you can do this. Exercise is really an important characteristic of moving forward. You build your strength up. And they're really kind of not difficult problems, but I'm not going to say each problem is going to be equally easy, but they're, for the most part, they're not bad. Take a look at it. See if you can get through it. Yes, it's work. Yes, it takes time. Yes, you'll improve your skill set by doing those. There's about 20 problems there. Not 20, exactly 20 problems, right? And then, of course, you know what happens. There'll be this related Sage code over here. And related Sage code, why do we do this? It's a computer algebra system or a CAS. It's free. You go to this website over here. You can download the application or use the interactive web-based application. And this is something we introduced really early on in the course about how to access Sage, including a free book if you want to, improve your skill set with that. But again, reset, what does that do? Clean sheet of paper, define your variables, and lo and behold, the word factor. And what does factor do? It factors the algebraic expression. And Sage does a remarkable job in factoring. It really does. A remarkable job. But the bottom line, you really need to learn how to do things by hand. All right? Now, again, if you need to reach out to me, I just want to remind you again, I know it's rather repetitive, but that's my email address. No, I'm not encouraging you to reach out to me. What I'm saying, if you need to reach out to me, please reach out to me. Okay? Now, again, this thing has not been published for everyone yet. It'll get there. And when it gets there, I'll make an announcement. But this is for the Prison Mathematics Project participants only, except for the videos. Anyone can watch the videos. So someone's going to say, well, I still want the document. If you go back to the original videos, I told you how to get the original textbook. I told you how to get a copy of it, both a PDF copy and a physical copy of it. I also warned you about people selling the copies of the book, right, that are just simply reprints. Don't go near those things, all right? Now, what's the advantage of my text? It's been retyped, and I've added tremendous amount of material to it. What's the material I'm adding to it? Basically, some simple explanations, in the problem sets, and also I actually give solutions to the problems where Wells doesn't. Sometimes he gives a simple answer and he just simply says, oh, it's just obvious or something. It may not be obvious. So I put a lot of work down for you. All right? Hopefully this has been helpful. But again, I'm not saying videos are helpful for students. You decide what's helpful. Is reading helpful? I hope it is, because reading is the foundation. But the bottom line, it might be a variety of ways of getting help, including reaching out and getting a tutor to help you. All right, thank you so much for paying attention.